Okay, in this video we're going to learn are there homologs of the protein we're analyzing in other phage genomes, and we also want to find out what were people assigning for functions for that particular protein fam. We'll use BLASTP in both Actinobacteriophage database and the GenBank NCBI database, but we're also going to go to the phage page for that gene fam and look at the list of functions assigned to that family. So let's start with what we see in Pecan. This is just a screenshot showing the BLASTP hits in the Actinobacteriophage database. Things to note. What cluster are these hits from? So all of these genes are in cluster K1 genomes. What are the E values? I've circled just some of the top hits. The E values are 0, again, meaning we have really high quality hits. Here are the phage names that have this fam and what gene number they are. They are all located in about the same place, gene number 9. And they pretty much all have a portal protein gene function assigned to it. So let me show you what this looks like in a live Pecan page. So here I am at the gene I'm calling gene number 9 of Clipper with a stop 4599. Scrolling down to my PhagesDB database, this is the same data I just showed you, but what I've done is I can add check marks. Maybe I want to add Twitch to show my instructor which pieces of data I use to support my gene call, and I can push save. What that does is move those pieces of evidence to the top of the table for my instructor to see later on. We can scroll down to BLASTP against the GenBank or NCBI database. Remember that this is a database that holds all kinds of sequences. It has published phage sequences, but also bacterial sequences. Cluster K1 is a really well isolated phage, so there's lots of cluster K phages in the GenBank database. So pretty much all of these hits that you see here are to cluster K1 genes. However, if you have a more unusual phage sequence or a very unusual gene that's not found in the Actinobacteriophage database, or not very many versions of it, you may get hits at GenBank to bacterial sequences. So you want to pay attention to whether or not you're hitting bacterial genes or phage genes. Okay, the last place I'm going to take you in this video is my favorite button when looking at function is the PhagesDB. I've already pushed this button. It's a link. It takes you to this page. It takes a couple of seconds to load, so I already have it loaded. And this is a neat page. You can access the starter rate report here if you need to. You can download sequences if you want, but mostly what I use this for is just to look at all the different function assignments. And they're pretty much all portal protein. There's some old annotations that say putative portal protein, but for the most part, these are all portal protein. I want to capture that in my electronic notebook. So first of all, let me show you that I took the BLAST data and captured that here under BLASTP alignments and function. Here I've written Clipper 9 matches portal protein functions of Adonis 9 and Veliki 9 with E values of 0. And of course, those are the hits that I selected on the Pecan page. But I also note that there are lots of other cluster K1 homologs. The next place that I need to capture in my notes is the list of functions assigned to phage in PhagesDB. I've noted that all of the functions assigned in this fam are portal protein. Well, that makes it pretty easy because it tells me the community agrees that this gene is a portal protein. But there are times that we'll look at the list of functions in PhagesDB and find people disagreeing on the functions. And I want you to list all the different functions that you see. And let me give you an example of a different gene in Clipper. This is Clipper GP32, and I've already clicked on the FAM for Clipper GP32. And this is a gene where people haven't done as much of their homework on the gene function and didn't agree on function calls for this gene. So some people think it's an MRE11 double-stranded break, endoexonuclease. Other people call this a metallophosphatase. Someone called it a phosphoesterase, an exonuclease. Some people down here just called it a nuclease. What I want you to do when you see this is write down every version of the function name that you see right here in your phage notes, because this gives us an opportunity to recognize that we're going to have to work a little harder on the function called for this gene. You will need to prove if any of those functions are correct, why they're correct, and why the other ones are not correct. So listing functions assigned to a FAM is important for recognizing when we have a gene that's going to need close scrutiny. Okay, that's it for consensus. In our next video, we're going to talk about how we can predict the structure of the protein and really figure out what the proper function is going to be.